Hello guys, today is a remote learning day, as you know, but you are going to want to do your Unit 5 reference sheet so that you can have it on your test this week. So I just wanted to go over that reference sheet for anybody who needed it, or a quick review for this unit. So you can find this on Kami, just right underneath this video. And I will also post my completed one for you guys that you can look at too. So the first one is about graphing in standard form. So remember, standard form is when an equation of a line looks like this, where you've got x and y on the same side. Okay. So the first thing we would do would be to find our intercepts. Okay. So to find your x-intercept, then you would plug 0 in for y. Well, if you plug 0 in right here, then this term becomes 0, and we don't usually write minus zeros. So really, we just have 2x equals negative 12. Okay, so then all we have to do here next is solve for x. So we divide by 2 on both sides, and we get that x equals negative 6. So that's our first point. Now with the y-intercept, it's basically the same, but in reverse. With y-intercepts, y-intercepts, x is always going to be 0. So same thing here. If we plug a 0 in here, well, that turns this whole thing to a 0, and this would be like doing a plus 0 out here. We don't usually write those. So really, we just have negative 6y equals negative 12. So we would divide by negative 6, and y would end up equaling a positive 2. Okay. So then all we have to do is put it on our graph. So we put the first one, the x-intercept, negative 6, 0. So we're going to go over 1, 2, 3, 4, 5, 6, and we're going to put a dot there. Okay. And then, I'm going to change some colors for you guys here. And then with the y-intercept, we do the same thing. Okay. We just go ahead and put it on our graph. Okay. And this time it's going to be at 0, 2. So we go up 1, 2 and put our dot. And then the only thing we still have to do is to connect those lines. Okay. Oh, that was really bad. Let me try again. Okay. So all we had to do was just connect them. That's not too bad. So there you go. Now you have your graphed line. Okay. So remember, anytime you're graphing in standard form, or when x and y are on the same side, you find your x-intercept, you find your y-intercept, and then you put them on the graph and connect the dots. Okay. So let's talk about graphing in slope-intercept form. You guys are usually a little bit more comfortable with this one, but let's just go over it again. So slope-intercept form happens when you have y equals and then other stuff. Okay, now remember, this is the form y equals mx plus b. So b is always going to be your y-intercept, and m is always going to be your slope. Okay, so your y-intercept in this case would be negative 4. But it's always going to be your b value. Slope in this case is 3/5. It's always going to be your m value. Whatever's in front of x is always your slope. Okay. So on this one, we start with our y-intercept. So we would go down 1, 2, 3, 4 and put our dot. Okay. Now this time, instead of putting another dot on a specific spot, what we do is we use our slope to get another dot. So this time, remember, slope is always rise over run. Okay, slope is always rise over run. So we are going to go up 3, 1, 2, 3, and to the right 5. 1, 2, 3, 4, 5, and we're going to put our dot there. Okay. And then the last thing is always just to connect your points. Okay. So I think you guys are a little bit more familiar with that one, but I want to make sure we don't forget that. Don't forget what you already know. So those are the two ways that I have taught you how to graph lines, standard form and slope-intercept form. So you have to be able to look at the equation and decide what you need to do. Do you need to find your intercepts, or can you just use what you have? It's up to you, okay? All right, now graphing inequalities. So remember, this is going to be really similar to the stuff up above here. So if you were given an inequality that has the same form, we've still got our y, our m, x, and our b, okay? So just keep that in mind that we still have that here. Or in this second one, this is in standard form, okay? I'm actually going to start with the standard form one. I know that it's on the bottom, but it's the one we did first, so I just want to do that one. So we are going to go over here, and we're going to say, okay, we need our x-intercept. Okay. So we would do if y equals 0. Okay. I guess I'll just put an arrow here. So if y equals 0, well, that would leave us with x is less than or equal to -2. So the point that we would use then is -2, 0. So we'd come over here and put our point on -2, 0. And then for our y-intercept, that's right here. So if x were 0, then you'd be left with -2y less than or equal to, and this should be a 2. I'm sorry, that is a typo. Okay. All right, so then on the first one, x is pretty much already solved for as soon as you put y in. This one's not, so we're going to need to go ahead and divide by -2. Now remember, in an inequality, when you divide by a negative, you do need to flip your sign around. And then that gives us the point 0, 1. Okay. So that would be right here. All right. And of course, we just have to connect our dots here. Okay. So, not too bad so far. Okay. So then let's go ahead and do the one that's in the other form again. So, oops. So the y-intercept again is going to be whatever is out here. So on this one, it's -4. But remember, it's always your b. Your slope on this one is 1/3. Remember, it's always your m, or your number in front of the x. Okay. All right. So I hope you guys noticed I am just doing the lines first, and then I'm going to talk about all the stuff that goes with an inequality. So the line, we would go down to -4 and put our dot there for our y-intercept. And then our slope is a positive 1/3, so that means I'm going to go up 1 and over 1, 2, 3. And go ahead and put my dot there. Okay. And then we could connect our lines. Okay, now, so that's just how you would do it if it were a line. But these are not lines, okay? These are not lines. They are inequalities, which means we do need to take a couple more steps. So the first step we need to take is this. We need to decide if these lines really should be solid or if they should be dashed. So we're always going to look at our sign here. This one's a less than or equal to. It should stay solid. Okay, it has an or equal to right here. It should stay solid. Now the top one, this is a greater than sign. It should not be solid. Greater thans should be dashed lines. So I'm going to go back in and go ahead and make this a dashed line because that's what it should be. Okay, it should be dashed. Okay, all right. So then the next thing that you're always going to have to do is shading. Okay, so we're going to start with the second one again, and we're going to do our shading. So with shading, you have to test a point. Okay, you're always going to need to test a point. I always recommend 0, 0. Okay, so what we do is we plug zeros in. So we would say, okay, if we plug 0 in for x, then that's 0. Minus 2 times y is also 0, less than or equal to -2. Then we're going to simplify. Well, this will be 0. This will be 0. 0 minus 0 is just 0. And we're checking to see, is 0 less than or equal to -2? No, 0 is bigger. Okay, so we're going to go test of point 0, 0, we got a false statement. So we want to shade the other side. So from this line, 0, 0 is right here. It's down here. Now we do not want to shade that area for this one. So we would shade up above. Okay. So for this one, the shading looks something like this. Okay. All right. Now for the second one, we're going to do the same thing. We're going to test the point 0, 0. So this time we're going to plug 0 in for y, greater than 1/3 times x should also be 0, minus 4. So then we simplify. That's just 0. 0 minus 4 is negative 4. And we check and see, is 0 bigger than negative 4? Yes, that is actually true on this one. So we're going to say true. So for this one, here's 0, 0 in relation to this line. That's above. And in this case, we do want to shade that all in. Okay. So we're going to take this line, follow it, and then we're just going to keep going up the whole way. Okay. Anything above that line is just fine. Now remember, the dashed and solid lines, what those mean are included or not. Okay. So in this case, in this very specific case, this line is included in that inequality. Any of those points will work if you plug them into the equation. Now, this bottom line is a dashed line. These will not work. Any points on this line will not work in this inequality, okay? That's what we mean by included or not. So let's just, let's pick a point that is on this line and see what happens so I can kind of show you. So on this one, if you picked the point like, well, let's do the intercept. Let's see what happens with the intercept. So x would be 0 minus 2 times y is negative 4. And if that's true, it's going to be less than or equal to negative 2 for this bottom one. So again, this would be, oh, I'm sorry. I'm doing the wrong line. I apologize. Okay, so let's go back to the right line here. So it should be y, which is 1. Sorry. Nope. Negative 4 should be bigger than 1/3. The x is 0 minus 4. So we're going to test it out. Negative 4 is greater than 0 minus 4. Negative 4 is greater than negative 4. Now this is not true. Negative 4 is not bigger. It's equal to, but it's not bigger. So that's what happens when I say it doesn't work. It doesn't produce a true statement. Okay? All right. We're going to go ahead and move on. Okay, so remember substitution. Okay, so when we use substitution, okay, is when we have something that is pretty much always already solved for y. If it's not, you may need to solve it for y. So for example, if this top one didn't say this, if it said y plus 2x equals 3, then you would need to get y solved for. Now, that's not what it says. They already did it for you, so you're okay. But keep in mind, if I tell you to do it with substitution, there is a chance that you would need to solve for one of the variables, okay? So just keep that in mind, that that's the case, okay? So when you solve by elimination, you do something completely different. So please make sure that you're paying attention to the directions on your test. It will tell you how I want you to solve it, and you do need to solve it in that specific way in order to get the credit, okay? So please, please, please just keep that in mind, okay? All right, so substitution. When we have substitution, we take whatever y is equal to and we sub it in to y in the other equation. So for example, for this one, we would say we're going to take the 2x plus 3 and we're going to substitute it for y in the second equation. Okay, so what we mean is we're going to take this whole thing and instead of using y here, we're going to put it in. Remember, it's like nicknames. You can call it either one. It is y. It could also be 2x plus 3. It's a nickname versus real name. They're going to answer to both. Okay, so you do that, okay, and you say 2x plus 3. Remember, I always put parentheses around it. It's just habit. You don't necessarily need them, but it's better to have them and not need them than need them and not have them. Plus 2x equals negative 9. Now, this doesn't have anything like a 3 out here multiplying by it or anything, so it turns out we actually didn't need the parentheses in this case, so you can get rid of them. Okay. So then, the next thing we would do would be to combine our like terms. So we've got a 2x and a 2x. That gives us a 4x plus 3 equals negative 9. Now, the reason we're doing all of that is because we should be solving for x. Okay. So then if we're trying to solve for x, we would move this 3 away. So we'd say 4x equals negative 12. We would divide by 4. And x would equal negative 3. Okay, so we got that. Now, the solution has to be a point. Okay, it has to be. So, we pick an equation, it doesn't matter top or bottom, and we substitute the x value into the equation, and we solve for y. Okay, so what we do, we take this x, and we would write y equals 2 times by 3 plus 3. Okay, so you see how it's just this first equation, but instead of an x, we're going to use 3. If we know what a variable equals, we no longer need the variable. Okay, and then the next thing we're going to do now is we're going to solve for y. Okay, so we would say y equals 2 times 3 is 6 plus 3, and y equals 9. So those are your x's and your y's, but remember, you have to write it as a point. So you're always going to write it as negative 3, and then your y9. Sometimes you'll end up solving for y first and then your x. That's fine. Just keep in mind that ordered pairs are always x first and then y. So when you write your answer, make sure your x goes in the right place and your y goes in the right place. Okay. All right. Next, solving systems using elimination. Okay. So I gave you guys different steps than are here. Okay. So just keep that in mind when you're doing that you need to be careful. Okay. I gave you slightly different steps. Okay, so my step 1 was always to write them stacked on top of each other. We already did that for you. Now step 2 is right here. Look for opposite coefficients of x or y. So what we're saying is we're looking for the matching ones. Okay. Now in this case, we don't have matching on either. So we're going to have to multiply one or both by something to get these to match. So I'm noticing right here with our y's that 2 and 4 are pretty easy to multiply. 3 and 5, I'd have to multiply something by each of them to get where I want to go. But with 2 and 4, I only have to multiply this top one by 2 to get there. So I'm going to go ahead and multiply this whole thing by 2. So remember, that means I would distribute into every single term. So 2 times 5x would be 10x. 2 times 2y would be 4y. And 2 times 6 would be 12. Okay. So now, again, you're going to double check. Do you now have matching coefficients with opposite signs? You do. So we can go ahead and add these together now. Okay. So add the equations. Okay. So negative 3x plus 10x would give you 7x. Negative 4y plus 4y would give you 0y. And 2 plus 12 would give you 14. Now remember, 0y, if you do this, it does not matter what y is, it's going to be 0. 0 times anything is 0, so that would really just be 7x plus 0 equals 14. Or you could just say 7x equals 14. Okay. So then the next step is to solve for x. Okay, we've got to get x by itself. So we're going to divide by 7, and our x equals 2. Okay, now we have to take that and plug it in to one of our original equations. Okay, so I'm going to do the top one. It really doesn't matter, but I'm going to do the top one. So 5, but instead of x, I'm going to use a 2 plus 2y equals 6. Okay, now we can go ahead and simplify here. So that's going to be 10. 5 times 2 is 10 plus 2y equals 6. Now we need to solve for y, right? We have x, we need y. So we're going to go ahead and minus the 10 from both sides. So that would be -4. Okay, and I'm going to change that color. Sorry, guys. And then you would divide by 2, and you're going to get that y equals -2. Okay, so you have to check your answers. Okay, so we are going to write these into our solutions here. That's going to be fine, but I want you to always check your answers. Okay, so it shouldn't matter which of these two equations you plug them in, but if you plug this x and this y in here and here, or here and here, you should get true statements out. So let's go ahead and try that out. So if we do the top one, we would get 5 times 2 plus 2 times -2, and that should come out and equal 6. And for the bottom one, we should do -3. Instead of x, we're going to use a 2 plus 2 times, -4. Read that wrong. 4 times -2, and that should equal 2. Okay, so these you can just check them in your calculator. Remember, you can just check them in your calculator. Okay, I can do these in my head, but it's okay if you can't. Use your calculator. Type it in exactly like you wrote it. So 5 times 2 is 10. 2 times -2 is -4. So 10 minus 4 is indeed 6. That one's good. Okay. Now the second one. -3 times 2 is -6. -4 times -2 is a +8. So -6 plus 8 is 2. That one is also good. Check it off, smile it. That's definitely your answer. Okay. All right, if you have any questions on this, please let me know. You should be working on your review today. We will also be working on your review tomorrow in class. So my hope is that you guys will do it on your own from home today, so that the ones you get stuck on or the questions you're not sure how to do tomorrow, you can ask me questions in class. So if you have any questions, definitely let me know, and I will see you all tomorrow.